This is a video for Statistics 252 on the homework for Chapter 3. Let's start off with some definitions. And if you aren't sure where these definitions are, you can look at the heading or the first page of Chapter 3 and you'll see all these definitions listed right there, or at least these terms listed right there. So we have, in this chapter we're looking at trying to get some numbers. We're going to calculate some numbers on how the data is organized, not just in the classes, but how the data values are sort of grouped. And we look at three things. We look at what is the average value, and there's actually several averages, 3 averages to be specific. There's some more too. So what is the average value? That's something typically you'd ask. What's the average value of, I don't know, the average wealth of a person in the United States, something like that, an average value. Then how is the data dispersed? That means how is it spread out all over the place? Do you have a lot of extreme values and the average is just sort of an arithmetic value, or is all the data kind of clumped towards one value? So that's the second question, how is the data dispersed? And the third is, how does one point rank with respect to the others? If you get a 45 on a test, where is that with respect to the others? That's the highest point in the class, or is that the at the other end? So in statistics, these terms have special names. Get rid of that. Okay. What is the average? That's a measure of central tendency. A bit hard to remember, but central is the operative word here. And what kind of measures are there? There's mean, median, and mode. There are weighted averages. Okay, and there's some rules of thumb, but the main ones are mean, median, and mode. You probably remember those from previous classes. How is the data dispersed? That means how is it spread out with respect to that average? And these are measures of variation. That's the word that goes here, variation. And what are the two that we talk about? We talk about variance and standard deviation. And there's special symbols that go along with these. Actually, it's the same symbol because they're related. Variance, and the other is standard deviation. That's an S. They're related because the standard deviation is a square root of the variance, so they use the same symbol for them, which is okay. If you have a population, then what's used for variance and what's used for standard deviation is the Greek letter lowercase sigma. Remember the uppercase sigma looked like this and it meant sum. That's uppercase Greek sigma. Lowercase looks like this. And the variance, which is just the square of it. So you use the same symbol. If you're using a sample, it's S and S squared. I'll be using the Greek letters a lot because I just want you to get used to them. So a variance and standard deviation using the same symbol. The variance is squared, the standard deviation is the square root of that. I should also mention here the mean has a special symbol too. Okay, if you're working with a population, it's mu. That's Greek lowercase m. Doesn't look like an m, but that's a mu. The other symbol when working with a sample is x with a bar over it, meaning average. That's very common also in maths to put a bar over it means average. However, when we get to chapter 4, it will have a different meaning. So here's mu, meaning the arithmetic mean. Variance, the sigma. And how does one data point rank with respect to the other? This is a measure of position. What's its position in the group? And these are the way that scores are frequently reported on the standardized test. You have percentiles, which is not percentages. Percentile off with a P. Quartiles, which are very useful, which is your Q. And then you have Z-scores. And those will be used a lot too in this class later. in this chapter there's quite a bit of calculations compared to the other two. Start off here with a list with some data. So you're given this data set: expenditures per pupil in selected states. How many states? 15. Okay. You need to write the formula for the mean and find the mean for the state. Okay, I want to see the formula. Okay, I'm going to use mu here. You could use x bar. And how to find the mean is to add up all the values. Remember, values are generally denoted with an x, and divide by the total number that you have. That's a capital N. If you're working with a sample, you might use x bar. Okay, so you add up all the values. So you'd add all these values up, and then you divide by however many you have. In this case, you have 15. And that will give you your mean. That's the mean for the data. The median and the mode are found, I'll write mode here instead of going to the next page, in a different way. What you do is you take the data and you line it up from greatest to least or least to greatest. It doesn't matter. So you look for the smallest number, you write that here. So I've got 6,491. Then you go up and find the next one, which looks like it's 7,400, 7,552, and you keep going all the way up. Right, and the top one looks like, I write these myself, you think I could remember what they were. Okay, 11,847. So you've got all of them lined up. That's what you have to do. You have to order the data from least to greatest, or you could do it the other way, it doesn't matter. Now you have 15, so you go right in the middle. So 15 divided by 2, alright, so you're going to come all the way up here and you're going to count off until you find the middle value. When it's odd, it's pretty easy to do. But in this case, I would count up to the 8th one, and whatever the 8th value was, that would be the median. Okay? If you have an even number, let me just give you another example here. Oh, okay, I'm going to erase the screen. We'll just take, not these numbers, but some other numbers. Let's go 4, say 7, 12, 13, and 19. If that's my data and I line it up and it's an odd number, then all I have to do is pick the middle one out, and it would be 12. 12 would be the median. And now let's look at the case where I have, say, one more number. Now I've got an even number, so there's no middle one to pick out. Instead, what you pick out would be these two, the two middle ones, and you average them. So the median now, because there's no one particular number, would be the average of those two. So if you want to find the average, you go, well, obviously this is easy, but you'd have the two numbers, add them together and divide by 2. In this case, you get 12.5, which you could do by inspection. That's how you find the median. Write the numbers in order. If it's an odd number, just pick the one in the middle. If it's an even number, find the two in the middle and average them. Now the mode is the number that occurs most frequently. Let's say you have, I have to put some more data here. Let's put another 7 here. Let's put another 27 out here on the end. And we'll put 3 4s. These are all different ones. Okay, if this is the data, to find the median, you know how to find that. You just go in the middle of this and pick out the middle number. I think we have an odd number. No, we don't. We've got even numbers, so you'd have to average. Alright, I'm going to go over that again. So the average would be these two numbers, and you take those two numbers, you go 7 plus 12, I think that's 1, 2, 3, 4, yeah, over 12, and you divide by 2. Okay, what do we get here? It'd be 9.5. That would be the median. For the mode, you look at repeated numbers. The first way I wrote this, there were no repeated numbers, so there was no mode. Here, you can see, okay, you've got 3 of these. You have 2 of these. You've got 2 of these. The rest are in ones. So in this case, the mode is 3. If you didn't have the situation, say you didn't have that 4, so you have 2 of the 4s, 2 of the 7s, and 2 of the 27s, then the modes, mode can be plural, would be 4, 7, and 27. The way I think about mode, it's if you worked in a shoe store, you would look at the shoe sizes that sold most often, and those would be the modes, and that's what you would want to reorder. That's one way to remember mode. In this problem, on the actual homework, you would be doing the rest of these C, D, and E. You'd be doing those for that data set on the pupil expenditures, on the data that was given. But here, just to explain to you what's going on, I'll use this simpler data set that just has some integers in it. Okay, so the question now is to find the quartiles, Q1, Q2, Q3. Don't forget that there are written lectures that summarize all this, and I think you benefit from looking at those. Okay, what are these quartiles? Here's how you do it. For Q2, you find the median of the data set. So I've got this organized, so I'd have to go in the middle. And it's going to be a 9. Change color. The 9's the middle number when it's all organized like that. So here's your 9. So that's the median. So Q2 is the same as the median. In this case, it's 9. For Q1, you look at all the numbers lower than the median, and you find the median of those numbers. So if I've got 0, 1, 4, 4, 7, here's the median for those. So Q1 is the lower median, and that's 4. For Q3, well, you would look here, and you would find a 25. So you find the median, overall median gives you Q2. The median of those below it is Q1. The median of those above it is Q3. So this is Q1. I'll write them here. Q2, Q3. The interquartile range is Q3 minus Q1. In this case, it'd be 25 minus 4, which would be 21. You use that to find what you would call outliers. So it just gives you a range where actually most of the data is clumped. List the 5-number summary for this data. The 5-number summary is the lowest number, so that's 0. Then it's the Q1, Q2, and Q3 make up the rest of those numbers, which would be 4, 9, and 25. And then the and then not Q4, and then you get the highest one, and that would be 27. So that's a 5-order summary. You put the lowest value and the highest value in the 5-number summary, so that encompasses all the data values. Then you give Q1, Q2, and Q3. I'm going to write those numbers here again, and I have to do a box and whisker plot. So the lowest was 0. Q1 was 4. Q2 9. Q3 is 25, and the highest number was 27. Now there's different ways to do these box and whisker plots. So when you see something in a publication or in a book somewhere, and you see a box and whisker plot, look at how they did it. The way I'm going to have you do it here is the way that is described in the book. There's something else that's different about these box and whisker plots. Before, when we're doing histograms, here would be the values, would be right here, and this would be the frequency. How many of them you had for this value, how many in this class, how few in this class, like that. Okay, so the vertical axis had great meaning. It meant the number that occurred, or the frequency that they were occurring, at which they occurred. And those are the data values. For box and whisker plot, the vertical dimension is just a, just a drawing. It doesn't have any value at all. What it is though you took the numbers and you lined them up. You need something like this. Okay. So here's my 0. 20. Okay, so I put some tick marks every 2 for this particular data here, and then I go a little bit above it. To do the box and whisker plot, I'm going to put a dot at 0, that's my lowest number, and a dot at 27, should be about here, and then draw a line between those two numbers. Sometimes you don't draw the line, but I usually draw the line. Okay. Now at Q4, you put a vertical line. The height of it has no meaning. Then at Q25, you put another vertical line. Those are the hinges. Now you connect these up, and there's your box. Of course, the whiskers are the little part that extends from the box. Now right here, you put another line at Q2. And so what we have here are what's called the hinges. This is a hinge at Q3. Here's a hinge at Q1. Q2 is denoted by a vertical line in the box. It sort of gives you an idea of how the data is. Let me connect that across. And this is your, down here would be your lowest value. And up here, it ends at the highest value. So there's your 5-number summary, and there it is in a box and whisker plot. If you had the data points would be like, let's see, 0, I think there were 2 4s. And we just put them on here, 4, 4, there's a 7, here's the 9. I can't remember all the data points you have, but let's just give you some here. I need a few more. Okay, it's as though the data points were just dots on the line, on the whisker line. And the Q1, Q2, and Q3 make the box around them. By the location of Q2, you can get an idea whether this data is symmetric about the median, or not. So if it was very symmetric, that Q2 would be right in the middle, but it's not. So it gives you an idea of how the data is. Now the other way people do it is they use the interquartile range, and they use that to get the smallest value and the largest value within the interquartile range, and anything that's outside of that value they use an X for. Those are called your outliers. So when you see a box and whisker plot with X's out here, that means that there were some outliers beyond the interquartile range, and they're just showing you those. But here you can, instead of doing that, you can just put a dot for them and then connect them up into the whiskers.